Okay, so for this video we've got two practice problems, two examples of arguments where you need to use existential out. These are the example problems on page 27 of slideshow 17. So the first one's right up here. I've already written down the premises and the show line. We just need to figure out how to proceed here. Now, we know that every C is an S and something is C, and we want to show that something is S. So how should we proceed? Well, we want to get rid of those quantifiers and make the x's in both cases match so we can do arrow out and derive that something has property S, which is what we want to show here. But there's a question about what to do first. Do we do universal out or existential out first? And you might want to think about this before you hear what the answer is. In a case like this, you always want to do existential out first. That's because there's a restriction on existential out. If we do existential out, our x here gets replaced with a new constant, a constant that hasn't appeared before in our proof. Whereas universal out has no such restriction. If we did universal out first, say to make this CA arrow SA, then we wouldn't be able to use A here when we do existential out on line 2. So we'd like to do our existential out applications first. So I'm going to say CA, that follows from line 2 by existential out, and that's an acceptable application because A is a new constant at this point. It hasn't appeared earlier in the proof. It hasn't appeared in line 3, 2, or 1. Now, we're going to do universal out with line 1 to get if CA, then SA. That also is allowed because there's no restrictions on what constant we can use in universal out. We can make the x anything we want, even if it's an old constant, as it is in line 5. Now we're going to apply arrow out from lines 4 and 5 to get SA. And finally, to complete our proof, we just need to do existential in, which we discussed in the last set of videos. So there we go. That comes from line 6 by existential in, and we're done. We've got a direct derivation, so we cancel in box. Relatively straightforward. The important point here is that you need to do your existential out moves before you do your universal out moves, because you can match your universals to your existentials, but not vice versa. Let's do a second practice problem, one that's slightly more complex. So we've got two premises and a conclusion, and in this case it's important to remember, or to recognize rather, that your show line is a conditional. And whenever your show line is a conditional, you want to do conditional derivation. So this is something from the sentential derivations. So we get to assume BA, and now we're going to try to show the consequent, that something is not A. Okay. So how are we going to do this? Well, the first thing to note is to note something that doesn't have to do with existential out, but rather has to do with existential in. That is, from line 4, if we know that A has property B, we know that something has property B. In particular, we know that that's true. That comes from line 4 by existential in. Why did I do that? Well, if you look at line 1, that's the antecedent of our conditional. Now we can do arrow out to get the consequent. So we're going to get everything after the arrow. That comes from lines 1 and 6 by arrow out. Okay, what do we do now? Well, we've got a universal quantifier here with if not B, then not A. And we've got an existential quantifier here with not B. So we can do something like what we did on the earlier proof. And remember that we want to do existential out before we do universal out. So we're going to take off this existential quantifier and transform this x into a new constant. But here we have to be careful, because if you look, there's already a constant been used earlier in the proof. You see on lines 3 and 4, we have A already. So we can't use A in this case. we're going to have to use a different constant. I tend to just use the next one in the alphabet just to stay organized. So in this case, I'm going to do existential out with line 2 and replace that x with a b, because that's the next constant that's unused, that's new at this point. So I'm going to get not b, b. That comes from line 2 by existential out. And again, it's an acceptable application of existential out because b is at this stage in the proof new. It's a new constant. Now we can do line 7 and make the x's in here match what we have in line 8. That is, we can do if not bb, then not ab. That comes from line 7 by universal out, and since universal out has no restrictions, that's an acceptable application of it. We're almost there. 8 and 9, you should be able to see we can do an application of arrow out to get not AB. And finally, we finish up the proof by doing existential in. If we know that B does not have property A, then we know that something does not have property A. That's existential in. Oops. So existential x, not A, and then we replace the B with an x. That comes from 10 by existential in, and that's what we were trying to show. So that's a direct derivation. We box and cancel. And that completes our conditional derivation because after assuming BA, we are able to show the consequent. So that cancels, and we box everything down there.